Galapagos in Spanish means tortoise. And here in the pit of the volcano Alcedo, they've assembled in quite some numbers to wallow in the warm volcanic mud. A big one can weigh as much as 1/4 of a ton. They live for up to 100 years or more, which makes them amongst the most long-lived of all vertebrates. And being reptiles, they get their energy by basking in the sun. But their bodies are so big that once they are warmed up, they can carry on browsing for quite a long time. Fungi. Fungi can't photosynthesize because, unlike plants, they have no chlorophyll. In fact, they're more closely related to animals and are made of chitin, the material insects use for their skeletons. These are the fruiting bodies of a fungus. Their function is to produce dust-like spores, which are then blown away through the woodland to grow elsewhere. But these are only a tiny part of the fungus. Most of the body of the fungus is beneath the ground, a tangle of tiny threads which extend for hundreds of yards through the forest. And we're now beginning to realize that those threads are essential for the growth and health of many of the woodland plants. This mantis is far too large for any single spider to attack. So instead, they collaborate. All the nearby spiders help to hold it down. Even the smaller, young spiders lend a hand. Eventually, when their prey is exhausted, the spiders feed. It's not unusual for spiderlings to eat the bodies of older spiders that have died in the web. In fact, in some species of social spider, the mother always dies when the spiderlings hatch, and they feed on her corpse. So the generations pass and the family thrives. This vast web will persist for perhaps 5 years until eventually the family moves on. By living together as an extended family and all looking out for each other, these social spiders have helped guarantee their survival. But some insects have taken this practice a stage further. Family members have begun to specialize. This is a lava lizard. There are lots of them on the rocks around here. And in the breeding season, which is now, the males are competing with one another, both for territory and for females. And the way they do so is with press-ups. Watch. Actually, this is a model that is used by scientists to investigate the way in which these lizards communicate with one another. Let's see how he gets on. And there's a response. These press-ups vary, both in the number and the intensity, the speed at which they do it, and how high they bob their heads. The interesting thing is that the responses vary from species to species. In other words, each species has its own language of gestures. This bud will soon become a leaf. It's no ordinary leaf. It has a special, altogether more sinister purpose. This is Nepenthes, the pitcher plant. It grows in nutrient-poor soils, so has to find nitrogen and minerals in another way. The leaf, just like a flower, attracts insects with a reward. The pitcher is coloured and scented to appeal to flies looking for a meal of rotting flesh. The visitors are rewarded with a greasy substance on the underside of the pitcher's lid. But the plant wants something in return. Not pollen, but a meal. The lip of the pitcher is covered in tiny, slippery ridges. Wax lubricates the surface further. It's extremely difficult to hold on, even for a fly. Once inside, there's no escape. The leaf holds a pool of digestive liquid. This contains microscopic elastic filaments which give it the properties of quicksand. The more the insect struggles, the deeper it sinks. Enzymes begin to dissolve the victim's body while it's still alive. Some pitchers aren't content with just insects. This one eats mice. The mice come along, perhaps attracted by the sweet nectar on the lip. They fall in, they can't get a purchase to get out, they drown, and eventually the enzymes in the pitcher's fluid dissolves the body so that eventually there's nothing left but a bit of fur and bones. A pink iguana. Until now, it was thought that the Galapagos possessed only 3 species of iguana. The black marine iguana that lives on the seashore, and 2 species of yellow iguana that live inland, feeding on cacti and other vegetation. This land iguana is certainly the most closely related to the newly discovered one. Genetic studies of the 100 or so individuals that make up this tiny population have shown that it diverged from its land iguana cousins more than 5 million years ago. So amazingly, it has been here just as long as the other 2, but has remained unknown to science until now. The discovery also means that it is even older than Wolf Volcano, where it now lives. And of course, there is another great mystery that no one has yet explained. Nobody knows why it's pink. Could it be that to be pink up here brings something good? We don't know. Maybe this was once spread widely over the island, and this is just the relic population that's left. Again, we don't know. Goodbye.